good evening to you, depending where on the planet you are. And if you're not on the planet, thanks for joining from somewhere else. I don't even know how you're doing that. Anyway, this morning we're going to be talking a little bit about some fundamentals of Adobe ColdFusion. In fact, the particular fundamental we'll be talking about are structs. All right, we'll get into that a little bit in just 1 second. We had one question, though, that bears answering for everyone, and that is, will this be recorded? And the answer is yes. In fact, it's being recorded right now, so stay on your toes. And this will be available on our YouTube channel later on, probably in a couple days or so. So anyhow, let's get started because we have a lot of stuff to get through. Starting up. All right. Who's this guy on my screen right now? My name is Mark Takata, as I mentioned before, and I am the Senior Technical Evangelist for Adobe ColdFusion. What does that mean? Well, that means I get to be here with you today. That's what that means. And what is a struct? What are we going to be doing with structs? What are they? How do you create them? All that stuff. We'll be talking about that fairly soon here. Best practices and anti-patterns for struct usage. And then we're just going to get into some code. And by the way, there is a bunch of code that will be available up on the webinars folder inside of my GitHub. So you'll be able to go and see that there. So anyways, I mentioned Mark Takata, Senior ColdFusion Evangelist, third-year developer, polymath. So I know a lot of programming languages, 14 at the moment, looking for my 15th. If you have any ideas, go ahead and tell them that brick wall over there because I don't have time right now. No, I'm kidding. I'm thinking about Rust, maybe, as my 15th. I don't know. I think that might not be a good idea, but who knows? If you have some ideas, let me know, and that might be kind of fun. And I live in West Sac, California. Okay, enough about me. What are structs? What are structs? What is a struct? Why is it when you say struct to someone in a different programming language, they look at you like you grew some horns on your head? Well, so structs are just data structures inside of ColdFusion, and most programming languages actually have something very similar or identical to them. They're known as key value pairs, associative arrays, hashes. Essentially, every programming language out there has something like this because it's incredibly useful, incredibly powerful, as you'll see. Now, unlike arrays, in which you're basically having buckets that are lined up in a row, and you're putting things in those buckets, and you're saying, oh, if I want something out of the first bucket, I'm going to go ahead and go to bucket 1 because arrays in ColdFusion start at 1. We learned that last time. Here, we're actually going to give those buckets a name, a key, and that key is going to be alphanumeric. So it can be name or address or something along those lines. And then you're able to actually access the value inside of that bucket via that name. Very simple, very, very powerful. It also allows you to create groupings of these, which we'll see in a second, can be a really powerful way to build applications. And you're probably already doing it, maybe. All right, one thing to note, by default, out of the box, structs are not ordered. Okay, so what does that mean? That means that if you were to create a struct that had name, address, phone number, email, and then just spit it back to the screen, if you inserted it in that particular order, you may not get it back in that order. Why? Performance. Essentially. So there's some performance benefits to returning it unordered. However, if you do need it ordered, you can actually set a struct as an ordered struct. The performance loss, honestly, these days with computers being so powerful, not really a big deal. Something to think about, though. Now, you might say, well, wait a minute. Of course I want it ordered. Why would I not want it ordered? Well, think about that. If all that you're doing is taking the values inside of those buckets and filling maybe a form, like pre-filling a form with some data, well, you already know the keys. The keys there, the order that the keys come back out from your query don't really matter, right? So in many cases, actually, order doesn't really matter. But in some cases, it does. When? Well, for example, if you were to create some kind of a grid that returns back a struct, in the order that it's coming back for you, and maybe you're putting it as a column name and then a value in those rows, Well, sometimes you want those columns to be in a particular order, right? You probably don't want to start with address and then have name and then have email and then have city, right? So then it wouldn't really make sense. Not to mention for your users, you would want those to be in an order consistently across their experiences, right? So better user experience. So that's one example where actually having an ordered struct is good. This is one of the, I don't know if you want to call it a weakness, it's a foible or a just kind of a weird aspect of these guys, that you have to plan on what that struct is going to do for you in your application down the road. Okay, moving on. Structs do not maintain case sensitivity. Often you'll see the struct key get upcased. Why? Well, just to make sure that you can get a hold of it, right? And again, often it just doesn't matter what that key is, because most of the time you're not actually outputting the key, you're outputting the value, right? But again, maybe you are. Maybe you're taking that key and making a column name in a grid. I've literally written this in the past, and it kind of matters, right? Maybe you don't want it to be uppercased. I mean, I didn't, right? And so, however, again, just like ordered structs, there is a optional way to say case sensitive. So you can actually say, hey, maintain the case across this, right? Don't upcase, don't do any of this stuff. And then when you're actually testing, you can pass in multi-cased stuff like aardvark with an uppercase and aardvark with a lowercase, and those will be different keys. Okay, so that is an option. And if you want both, because you're greedy, if you want both ordered and case sensitive, there is actually a third option to do ordered case sensitive. So there you go. Now, one big thing, are structs JSON? Because they sure kind of look like JSON, right? There's like a colon between them. They're not. They're not literally JSON. I know they look like it, and they're very, very similar. And in fact, they're very strongly related. And through serialization, you can go back and forth. So you can like deserialize, serialize stuff that'll plop you back and forth between JSON and structs. And why this matters is you can't just take a JSON and try to plop it into a built-in function for a struct. It'll break because it's not one. You'd have to like actually create it. You'd have to serialize it into place, or deserialize it into place and actually make it work. So the problem there, though, is you have to be a little careful. Like the deserializers, sometimes they don't maintain things like order. Sometimes they don't maintain things like case. So if you're going back and forth willy-nilly, yeah, sometimes things can get a little bit lost in translation, and it's not so good. So just keep that in mind. All right. How can you make a struct? So there's a ton of ways. There's implicitly, there's explicitly, there's just adding stuff to a particular structure, right? And it's really similar, honestly. I'm not going to go too much into this. It's really similar to the same way that you do it in arrays, right? Lists are their own weird animal, often their space, right? And there's a huge list of built-in functions which work with structs, and that's really the meat of what I'm going to be talking about today. And the reason why is there's a lot of things you can do with structs kind of manually, and that's what a lot of us do and did prior to these being added to the language. What these do is efficiency, readability, making sure that your logic when you wrote your algorithm is correct. Well, ours are, hopefully. If they're not, let us know. But you can just use these particular built-in functions to do lots and lots and lots of really powerful things with your structs. And I'm going to show you 27 of them. That's right, 27. My age. No, nobody believes that. Anyway, but before that, like, so when should you use a struct, right? Because you kind of feel like, well, I mean, I could kind of like use an array. I get an array of arrays, right? Like arrays, you can multi-dimension them into, into confusing yourself really badly, actually, honestly. But so the first one is when order may not matter, right? And again, this is a fixable thing if you actually set them as ordered. But a lot of times, like the order of your data may, at the end of the day, just not matter. That's a good time to do it. When you have logical groupings of data, like what? So let's say you have an address book. Great example of that, right? Like every single one of those objects inside can be a struct. There's a name, address, phone number, blah, 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 right? All of those can be entered into structs, held to structs, used to structs inside of your application for looping through and all that good stuff. And by the way, a lot of you are saying, well, wait, like an array of structs, like, wait a minute, isn't that a query? No, but yes, but no. Very, very similar. In fact, you can, and I'll talk about this a little bit, you can actually do arrays of structs are one of the most powerful object hybridizations inside of ColdFusion. I use those all the time to loop through. They're very, very powerful. And that's what I would do in this particular case. Another reason to use a struct is when your data has consistent key names, right? So sometimes you just kind of don't have key names for stuff that makes sense to like sit there and loop through all over and over and over. Sometimes it's like, what did the user enter? And then take that and push it to the screen or push it to the database or something like that, right? Like you're just, what did someone enter as the second thing, the third thing, the fourth thing? Well, that's an array, right? Because it's indexed, right? That doesn't make any sense to be like, oh, user entry 1, user entry 2, and then having to loop, and that just makes no sense, algorithmically speaking. So that's another place where if you have like consistent key names that you can loop through, it's a good place for it. And again, if you have obvious key value pairing, so when you have the 1 and the 2, the 1 and the 2 type of things, especially in groups. So I just said the same thing like 3 times. Sorry. All right. When might you not want to use structs? I mean, honestly, a lot of times they don't make sense necessarily. They're very powerful, but a lot of times they're sledgehammers when all you need is, like a ball peen hammer. I don't know, like what's a smaller hammer than a sledgehammer? Literally any hammer, I guess. So the ordered to unordered piece can make planning more important than other structures. That's one place where if you're not quite sure how the data is going to go, I mean, hopefully you do, but maybe sometimes you don't. That can be a thing, and you can always convert things later, but things get messy. You have to be careful about like how your data is getting sent. It's good to plan. So if you have the ability to plan, great. If you don't, okay, you might want to consider other things. Other things such as you can actually create your own query object, and actually we're going to be talking about query objects next month. So we'll sort of offset that for a month from now. But query objects and arrays of structs are very, very similar animals in a lot of different ways, but queries have powers that these guys don't. So we'll talk about that next month. And that's what I just mentioned there. They work best when combined with other structures. So just using a struct sometimes is limiting. When you drop that into an array or like a multi-dimensional struct, like a struct of structs, things like that, that can be really powerful, right? And then again, care has to be taken when you're going back and forth between JSON, which a lot of us do, right? Like APIs rule the roost. Everyone's doing JSON this, JSON that. But ColdFusion is much more powerful when using its built-in structures like structs. Be careful when you're deserializing and serializing, right? So, all right. Let's play with code. Everybody want to see? Is anyone here? Is anyone actually like listening and having fun? Come on, show me some stuff in the chat. Yeah, there they are. There they are. People are here. Yeah. And by the way, if you have questions, which I'm sure you do, there's a Q&A pod. Go ahead and please put your questions in the Q&A pod so that I will have one place and one place only to go and check for things later on. Thank you, Zach, for putting the question in the Q&A pod earlier. So, Scott, you're fired, Scott. Actually, honestly, you're hired because that was a great pun. Scott Kelly says it's very instructional. Yeah. Oh, my goodness. All right. So what is this? What is this thing that we're looking at right now? So this is something I built. I'm calling it the Structs Factory. In fact, AI named it that, I guess. I don't know. I don't even remember. AI and me are basically inseparable at this point. So what this is a really, really, I'm starstruck. You guys are killing me. I love it. I love it. Keep them coming. Keep the puns coming. So what I'm going to do here is I can actually create a key value struct. So I'm just going to start off creating one name, Mark Takata. Let's see, email Takata at adobe.com, which, by the way, is my email. And feel free to email if you have questions about things. My email is always open. All right. So right now what we're seeing here is we have got a struct. It's not obvious that there's a struct because it's in memory, and this is the visual representation of it. But now we have a struct. There's a key value. The key is email. The value is Takata. The key is name. The value is Mark Takata. So here are some things, and I'm gonna have to like recreate some of these because as we're going along, I'm gonna be like clearing structs, blowing structs up, deleting them, and then having to do that. So please be patient with me. So the first one I'm going to start with is a very simple one: is struct. And why is that important? Well, because sometimes you kind of have to know if a thing's a struct, right? And why? Why would you need to know that? Well, errors, making sure that someone's not trying to enter something into your data that shouldn't belong, like someone's broken the object. It's really important to actually know, hey, is this thing a struct? And there's a lot of things that aren't structs, by the way. So here, I'm going to go ahead and test my current one, and yes, it's a struct. I would hope so. Gosh darn it. Okay, what about an empty struct? Is that a struct? Sure is. Still a struct. Even if it doesn't have anything in it, it is still a struct. And that is you have to keep that in mind, right? So just because you cleared a struct, that object, that empty struct object is still in memory, right? So this is a place where we can get ourselves in trouble if what we're doing is clearing structs and then creating new ones. You can actually create a memory leak in this, especially if you've got millions and millions of structs being, created, like a chat application or something like that, right? If you're using it for users to go and hit AI and bring back values, and you're creating structs, then clearing them and creating a new one for the next session, guess what? You might be in trouble. It's still going to be up there depending where you're holding it, right? So this is still in session memory. If you're holding it up in Redis or wherever, it could still exist. So keep in mind that still is a thing. What else is a struct? A nested struct. Well, that's not really useful because you can't actually see it. What about an array? No, not a struct. Not a struct. Strings are not structs, right? So anyway, all right, we're going to go ahead and move to struct append. This is very, very commonly used when going into your application. I showed you earlier that you can actually add information. You can set things in a struct. You can do all sorts of kind of implicit things. This is an explicit function that adds a value to a struct. Now, notice I didn't say it adds it to the end of a struct. Why? Because structs are not ordered in this case. Now, if your struct was ordered, then yes, it would insert it at the end. And when it came out, it would be the last thing, last in, last out here. All right, so I'm going to go ahead and I'm going to do screw it. I'll just do name, age, city. All right. So you'll notice something. I want to stop here for a second. So what this did was it added a city, it added an age, and it added a name. But what did it do? It actually overwrote my name, right? So this is a place you have to take care. You got to be careful here because during this operation, it will go and look and it will overwrite existing keys by default. Right. So you got to be a little bit aware when you're doing this, because otherwise you'd be like, hey, wait, wow, it just killed my data. What? I wanted to change the name and do whatever, or even error if it's trying to overwrite something that exists already. So be a little careful. It's a little bit of a thing that can happen. All right. So I don't like this. My name is not John Doe. My name is definitely not John Doe. I think. I'm pretty sure. Maybe it is. I don't know. Who knows? What are we anyway? But collections of atoms in space. Anyway, I don't like this. I'm going to clear it. And now, if I refresh the page, you will notice my struct goes away at the top. Right? So struct clear is just going through and clearing the struct. It's still there, by the way. It's just empty now, right? So, and in fact, if I test it, Funny. Funny, right? It doesn't show up at the top because there's nothing to display. But it's still a struct. It's still empty. It's still in there. All right. So I'm going to go ahead and go back and add some more stuff. I'm going to say F name this time, Mark. L name, Takata. Age, you wish. 29. Yeah. All right. So there you go. That's definitely me and not a much younger Mark Takata. Let's go to struct copy. Okay. So this is going to create a shallow copy of a structure. Right? Nested structures are copied by reference, not duplicated. So I'm going to go ahead and copy this. And there you go. And it made a copy of it somewhere else and dropped in the stuff. And it added a timestamp. Right. By the way, all this code is available. You'll be able to actually go through and see what all this looks like. Play with it, add it, do whatever. Jerry says, we built an app, essentially a spreadsheet that front-ended our ERP's Oracle database. Arrays of structs were instrumental in its design, running for 15 years. Yeah, Gary, they are magic, honestly. I mean, I think if you were voting for like the most powerful objects inside of ColdFusion, arrays of structs are, yeah, pretty darn close. I don't know. Query objects also are heavy hitters, though, as I'll talk about next month. But all right. So struct count. So what does it count? Does it count the number of structs? No, silly. It counts the number of items inside of the struct. There's 3. Okay. Why is this important? Well, you might be doing something like creating a grid and needing to loop a certain number of times, and you don't know the keys. So there you go. This is a way to tell how many individual buckets are inside of this particular object, right? Sub buckets. Let's call them sub buckets. So there you go. It's got 3 keys. All right. We're sick of this. We're sick of these lies, this false information, fake news. Mark is not 29. Come on. It's 25 at most. So what am I going to do? I am going to go ahead and delete that key. So there you go. And key to delete. Age key existed. Yes. Was there a result coming out of it? Yes. Originally had 3 keys. Now there's 2. And we're back to just first name and last name. So there you go. All right. Struct each. So looping through things, iterating through things, obviously super important. It's kind of what we do, right? Like programmers, like we don't just like throw stuff into the ether and not do anything with it. I mean, some of us do, but most of us don't if we're very useful. So in this particular case, what we're going to do is we're going to iterate, and then we're going to actually do a callback function for whatever the thing is that we want. So to start off, I'm just going to go ahead and just show the key value pair. So that's going to loop through. It's going to get the key name. It's going to display it. It's going to get the value and display it. Not super useful since you can see that up at the top. What about converting everything to uppercase? There you go. So that's going to do a callback and convert it on the way in. Now, keep in mind that didn't actually do the conversion back in. I didn't write back to it. And that's important here. This is a non-destructive thing that it's doing because that's not what the callback was doing. Okay. The callback was just going through and upcasing the values for display. Right. So as it looped, it would do the thing that you wanted it to do. So that's what I mean by a callback function. All right. Very, very important. Often we are looking for values, right? We may be trying to figure out what someone's last name is, right? We may be wanting to just display the last name for things. So I'm going to go ahead and say L name. Oops. If I could type, I'm going to go ahead and find the value by key inside of this struct. All right. And the value was Takata, which is my last name, amazingly. So there it is. Now, if I wanted middle name and I wanted to make sure that, maybe if it didn't find it, didn't error or whatever. In fact, I don't know. Will this error? How did I write it? Yeah, okay, no. So this is, I actually was catching this error, but if I wanted to, I could say set a default, or, maybe I say not found would be the default so that we don't get some kind of error or a non-existent thing. Oh, wow, that broke. Did I mention never doing demos with live code? Someone email me that as a thing to check later before I upload this code. Thank you very much. Okay, anyway. That's funny. That's hilarious. All right, anyway. That should have worked. You can set a default for outputting something if it's not there, I believe. All right. Now, here you can search for keys too, right? So if you're not really caring about the data, but you kind of want to figure out if there's like a key there, you can go ahead and look for a key pattern. So I'm going to go ahead and say, F name. And you can either get the first match only or all matches for it, right? So if you think there's multiple matches in there with that in there, it's there. So also though, if I wanted to just search for something that matched the pattern of name, nothing. Interesting. Why would that be useful? All matches. Yeah, what if you can star search? Anyway, I need to look into that. So, okay. So we've got struct find key, struct find value. So you can look for, that's not my name. So this is the other way, right? You're actually looking for values inside of your struct. There you go. And the key is lname, right? So it returns an array of structs containing match information. So this is more useful because there could be multiple Takatas, right? If you had an array of structs and you were like looking through it, or like different family member names, things like that, that could be similar. Struct filter. Okay. So this again is a callback, but this is going to go and loop through. It's going to iterate through your struct, and it's going to return back some kind of filtering mechanism that you put in, whatever that happens to be. And I have a few here. So, like numeric values, string values, things that are longer than 5. Okay, so let's say I just want to filter things down that are past the size. Just, I don't know why, because I'm being cheap. I don't want to return too much data. So I'm going to say, okay, only values with length longer than 5 should come back through. And there's only one of those, kind of, right? Obviously. Any values that contain the letter A? Well, they both do, right? So it's going to go ahead and return back Takata and Mark because both of those have A, right? So how about only numeric values? Well, none of them are numeric, so it's going to return 0. So very, very useful here for doing things like, returning back things that match particular patterns that you're looking for. All right. So if you want to return a value from a structure using dot notation, okay, you would use struct get. And so this is, like struct find, struct get. Like there's some maybe crossover, and some of these are older than others. I believe struct get is an older built-in function that was in some way superseded by struct find value, right? So if I want to get this, I would say, session, which is where I'm holding this in session, my struct dot f name. Everybody know what's going to come? Me, right? Mark. And here I'm also returning back the what type of value. It's a Java string, right? So that's pretty easy. And again, it's this is a maybe a more like explicit way of doing this, right? Because potentially you may have different structs in different scopes, and you want to make sure that you're getting it from the right scope. Now, of course, in ColdFusion modern days, we don't worry about that, because if we tried to get it without the scope information, it would blow up, because we don't allow implicit scope search anymore for security reasons. But in previous times, it's actually kind of useful, right? So, but here it's also in terms of like developer experience, it's very, very explicit where you're looking for the thing inside of your code. Struct get metadata. All right. So let's take a look at this. So what's metadata? Data is data about data, right? Data about the thing that's underlying. So here, what we're doing is we're looking at whether it's ordered, whether it's case sensitive. That's really it, right? There's two keys to this. And there you go. It is an unordered, non-case sensitive struct that I've created here. Because I haven't gotten to that part yet. Right, struct insert. So here we're gonna put in another key value pair into a structure. It does have a return, right? So you might be like, wait, struct append. Again, struct insert, struct append. There, I think one was put in. I think struct insert was later. Struct append was earlier. I'm not sure. It's one of those two things, right? They do similar things. So we can go in, we can put in a key. Let's say I want to put in my email, put in Takata at Adobe.com. Let's say don't overwrite if key exists, which is the default. You can also set it to overwrite here. And the thing with this one is it does actually have a return value that comes back from this function firing off if you want that. So you could actually use that to test and make sure that it's been successful, right? So it's a Boolean that's going to come back. So there you go. Oh, and I wrote it to actually put in more sample data too. Mark, what are you doing? Anyway, so there you go. Inserted my email. There's some sample data here too. I'm going to struct delete that though. Bad code. Okay, there we go. No one saw that. All right. So maybe we want to find out if a struct is case sensitive. We've done a lot of JSON deserialization. We've gone back and forth maybe, and we are just not sure at this point in our code whether a thing is a thing, right? Because maybe there's like an optional deserialization that happens, but it's important that a thing is that. So you can go ahead and test it. So current session struct, as we saw when we looked at the metadata, should be, it's not. It is not case sensitive. Wow, that is hard to read. I am so sorry. What that says in light orange on slightly darker orange is this struct is not case sensitive. And there you go. So, you know, a key that had an uppercase N and a lowercase n would be the same. Okay. However, if there, so I actually put a case sensitive struct in here and apparently made it easier to read. Green on orange, which is, wow, very Halloween-y. That one, of course, would come back as case sensitive. So you would actually get that data back, and you can kind of see it here. So I've output it, name and name, uppercase, lowercase. So that actually matters in this case. I'm going to do the same thing with ordered, as we saw earlier, is not ordered. Right, the current session struct is not ordered, and I put in a bunch more stuff into here so that you can see, you know, where the position is. And again, you can kind of see here, right? Like it's potentially going to be a weird thing for that to happen. So, and what I just did, I just refreshed it, right? So I inserted all of those values, and you saw when I inserted it was first, second, third, right? And then at the very end was the stuff that I had before. Well, guess what? Now when I refreshed it, it goes L name, then third, then second, then email, then first, right? Clearly unordered, clearly returning essentially at whatever the fastest performance speed it can get is. not super useful for some things, but honestly, I mean, it just sometimes doesn't matter because you do know the keys, right? So it doesn't really matter where the key comes back from. All right. So is my struct empty? Now, this is a really good place, right? Remember earlier we said if you clear a struct and then create new ones, now you're leaving empty structs in your memory, which could potentially create a memory leak, right? You could theoretically test if a struct is empty. So you could test if something was a struct, and if it is a struct, check if it's empty. And if it's empty, you could use it. If not, you could destroy it. I mean, there's all sorts of things that you could do, right? So here you go. Checked if mine was empty, and no, I have lots of stuff. There's tons and tons of data, right? Okay. Struct key array. Very useful. Very, very useful, especially, as I mentioned earlier, if you're creating something like a grid or something where you're trying to put all the keys out into the world for whatever reason, things that you could search for, like all of that, right? So that's how you're going to do. So you could go in and it will go ahead and drop in. It'll return an array. And we had 8 keys because of all that stuff. And there you go. Now here, I've actually put the values of them in, which is not what you're going to get back. You're actually just going to get back name, third, second, email first. Just wanted to kind of match those up, but really the array does not have all of that stuff in it. Struct key exists. Okay. So here's how we check to see if a particular key exists in a structure. We're not pulling data back now, right? We're just seeing if it exists. So this is going to return a Boolean. That's all. It's not going to return the value. It's not going to do any of that. So here, if I were to say middle name and check it, it's going to return 0 because I didn't put my middle name in there. I don't have that. Key just does not exist anywhere in the thing. So it's going to return a false or a 0 or a no, like whatever your favorite flavor of Boolean false is inside of ColdFusion. That's what it's going to do. All right. Now, earlier, we pulled back an array of keys. What if you want them in a list? Well, you can do that. There you go. So the key list would be name, third, second, email, first, fourth, right? All that. Why is this useful? Why would you do that over an array? Well, because as you folks probably, hopefully, all of you were there at my fundamentals lists talk. Lists are very powerful. They're first-class citizens inside of ColdFusion and have tons and tons and tons of amazing built-in functions, just like structs do, just like arrays do, just like queries do inside of it. And you may want to, in this case, go ahead and loop through it and do all the things that you need to do inside of it as a list. Easier to read often. Maybe you just want to list them out. And you can actually choose what delimiter you put in. So I have a few here that I put in that are, optional, but you can put in any delimiter. Generally speaking, it does have to be, alphanumeric and all that. That you want all of the all of the bad stuff and the oh no, this is going to break stuff for lists applies here, right? So you still have to be careful about using lists. We talk about that in that video. If you want to go see it, it's on the YouTube channel. All right, struct map. So maps are, if you're a JavaScript person, you probably use map a lot. Essentially, it goes through and iterates, and you write a transformation function. There's a callback function that goes in that is applied to each key value pair in the struct. So this is very similar to struct each, right? In this particular case, that's just kind of, they're both similar. Struct map is very new. It was really put in because the concept of map, things like map reduce, those were concepts that came in from the JavaScript world that people wanted to be using because they were familiar, even though there were things that could do very, very similar, almost identical things to them. So I'm going to go ahead and, do the old convert to uppercase for values trick, right? Can add a prefix to the keys if I wanted to, for whatever reason. Now, why would I do that? Well, maybe you're combining two different structs and you need one to be identified as maybe the old version. I don't know. Right. But you could do that. So map is very powerful. Map is one of those that you could do almost anything with. So keep that in mind. All right. And as you saw, I just did that for display. I didn't write that back to the struct. I still have, it's not 1, 2, 3, third, all of that. It's not in there. All right. Struct new. So here's where you have to be careful, right? So if you're writing an application, you're pulling in data and you're putting in a struct, you're playing with it, and then you're wanting to have a new struct or have something else happen or whatever it is that you want to do with that data, sometimes you'll struct clear it and then struct new. Well, again, you're creating an orphan struct inside of memory now that is, just out there, dead potentially if you've done it wrong, right? So here, if I wanted to create a struct new, I'm going to go ahead and just create it. Now, importantly, there's also ordered, case sensitive. Synchronized is not correct. What the heck? Sorry, guys. That one snuck in. Oh, wait. Okay. I need to fix that. So the third one is, so there's no normal. Just go ahead and ignore this. You can have an ordered, a case sensitive, or an ordered dash case sensitive. Those are the three types of special ones, or just nothing. Just go ahead and create one. It'll create an unordered, non-case sensitive struct that we've been dealing with all day here. I want to even know, what does a synchronized one do? Yeah, that's going to crash because it's not a thing. Okay. I'll fix that too. Sorry about that, guys. All right. So you saw earlier that there was metadata that came back from the struct. And it was kind of useful, right? Like you could use it maybe to see if a struct had some stuff. But of course, you can test if a struct is case sensitive. You can test if a struct has other stuff. But what if you want other metadata? Like, for example, a timestamp. If you want a timestamp on the actual, now I'm not adding it into the thing, right? I'm actually doing it on, this is on the struct itself, right? This is not a key value pair that I'm adding into the struct, right? You can do that. And why would you do that? Well, sometimes you want some extra information in your struct, right? It can be useful. However, fair warning, very, very important. This is an exceedingly expensive operation in terms of CPU. Okay, so getting and writing metadata for structs, be very careful doing this. I actually had a customer of mine that was doing this back in the day when you had to do things like maintaining, like in JSON, like maintaining things like types, right? What they would do is they would go through and get set metadata on a bunch of different structures, a bunch of different objects, and they would do it for students. And they would do it for thousands of students in every single call. And it was mind-numbingly slow because it was such an expensive operation. Now, by the time that I got around to doing this, all of those things have been fixed. Like we actually had stuff that, so I was able to just rip out all of these metadata, setters, getters, things like that, right? So this is one of those things, like think long and hard whether you want to do this. It's really powerful. It's really amazing. It's great, but be careful using it, okay? So if I go back here, oh, did that actually write that? Yeah, there you go. So now you'll notice I actually wrote that to my struct, right? And before, when I came here, all you saw was whether it was ordered or case sensitive. Now I actually went ahead and added another thing, which was a created key. Okay. And those can be really this metadata can be incredibly complex, right? You could nest things, like you could really make it powerful and hold a lot of data about your data, which is the whole point of it. But like I said, plan it out, right? Don't do this hundreds or thousands or millions of times in every page load. You will hate yourself. All right. What about sorting? So earlier we talked about how you can have an ordered or an unordered, right? But that's in insert order. So keeping that in mind, right? So it's similar like an array, right? Like when you insert a bunch of stuff in an array, it gets indexed, 1, 2, 3, 4, 5, whatever, right? But what if you just want to sort the values inside of here by their keys? So you could do that. You can actually go ahead and say, ascending, right? Or descending. Oh, I think maybe I'm not doing that right. Let's do it. Oh, I think I just crashed it. Sorry guys. Man, I need to work on my code. Let's take a look at what's happening here. I'm actually very curious. Sort type. Oh, that's the wrong sort type. Okay. I will fix this before I push this up. Okay. Anyway, moving along, we are getting really close to time here. Struct reduce. So I mentioned reduce earlier. Reduce is another one of those animals from the JavaScript world, right? It is also an iterative thing. It goes through and iterates through all of your stuff. However, the output, so you're going to go ahead and have a function, you're going to have a callback function inside of your reduce. The output is one thing, right? You accumulate everything at the end of it. So for example, I'm going to give the easiest one that I could do is concatenating all the string values, right? Like if you want to just have all of the things all in a row for whatever reason, you could also use it to count. So if there's a bunch of test grades you need to count, and there's output something at the very end of it, it'll do that. So here you go. So the reduced result is this incredibly long thing with a bunch of stuff together. That doesn't seem that useful, right? But actually it can be. Like if you wanted to create some kind of combo key, right? You could do it that way. If you need to plop two pieces of string together and have you could add a space to it. I mean, you could do all sorts of stuff to it. So that is actually a really powerful and useful thing. All right. And if we want to create a new sorted structure from an existing struct without modifying the original, this is going to return a new struct. And I'm going to go ahead and do that. So there you go. So that's a new struct with text keys as the ordering thing. And then update. Now here's another one of those where you're like, wait, I thought if you insert with the existing name, it just updates it. Well, yeah, it does, right? You can update a thing there. However, there's also in that particular thing options to not allow overwrites of existing things. So if you're inserting a bunch of stuff, like maybe you're using it for something different, it's not actually the right thing. Also, the name is wrong, right? You're not actually, if what you want to do is update, don't use an insert. That doesn't make any sense, right? So there is a struct update, and it has a value, has a return value that lets you know if it was successful or not, right? So I'm going to go ahead and change my name. It says name Jane, uppercase name. I don't like that. I want my name to be Mark. And there you go. Did the key exist? Yes. Did I update it? Yes. The old value was Jane, and the new value is me, Mark. There you go. So, and you'll notice something that, it's got L name, F name, and then name, right? But I don't have lowercase name. If I was to have, because remember, this is non-case sensitive, I would have actually overwritten the thing that existed already. But since we didn't have that, we didn't do that. All right. That's 50 minutes on the button. My goodness. All right. So that's structs, folks. Hold on. Boop, boop. Okay. So that's structs. Structs are incredibly powerful. Obviously, they are very, very useful. A lot of you probably already use them. Hopefully, I've given you some tools to use them even more efficiently, even more effectively. I'm going to be going ahead and throwing up into the GitHub. So it's at github.com/Adobe ColdFusion/webinars. You'll see one for fundamentals for structs. I'm going to go ahead and have my PowerPoint in there and all of the code after I fix a couple things up there later today, hopefully, or maybe tomorrow, so that you can grab it, download it, use it. The code is yours to do with as you wish. If you want to incorporate it into your stuff, great, go for it. If you want to use it to teach folks at your company how to do stuff, great, that's awesome too. Thank you so much for everyone coming. If you have questions, please throw them into the Q&A, or I guess you can go ahead and just throw them in the webinar chat, since now I'm actually paying attention to that and not staring at my presentation screen. Yeah, so questions, comments, concerns. Anybody like my hair? Whatever you want to talk about. Not you, Scott. I know you like my hair. I'm assuming everybody here uses structs. Is that right? Cool. I got a thumbs up and hearts. Yes, but should use them more. Absolutely. Yeah, Scott. They're super strong. They're super powerful. Cool, Rob. Appreciate that. Yeah. Very cool. I'm glad you learned a lot. I'm glad. Yeah, it's a really these things are really awesome. And that's why I do these fundamental classes, because a lot of us use like some of it, but there's so much more. Like ColdFusion is such a powerful language. There's so many features, so many things that we can use to make our code more readable, more efficient, more powerful, all that good stuff. Yes, and that's a good point. So Jeff M puts out that he likes the look of CF dump for struct. Absolutely. Yeah. And that's a really powerful thing, like dumping your data. Like, it's good to know what it looks like, right? Like the color differentiation, like arrays of structs, you can very clearly see that they're arrays of structs, all that good stuff. So yeah. Scott's been doing CF for almost 20 years. What? When did you start? When you were 4? Come on, buddy. But I love classes like this, the basic foundation, and it's good to get a refresher at. Thanks, Scott. Appreciate that. And that's the point of this is, this is teaching us old dogs new tricks, and, maybe teaching folks that are interested in ColdFusion what it's all about. And kind of giving them a look into like, hey, this is not some old dead language or whatever. This is a powerful, really, really useful and usable rapid application development architecture that you can use to build great apps and program in. You're very welcome. Awesome, folks. All right. Well, I am going to be gone. I'm going to go ahead and stop recording if there's no more questions. And I will stick around for another few minutes if we all just kind of want to chat. But I'm going to drop out for just 1 second while I finish that and then bring my video back up. So stay tuned.